Hey, what's up, YouTube fans? This is going to follow along the lines of many other videos I've made recently. I wanted to talk a lot about how, the biodiversity of life on Earth, right? The diversity of different species, one from the next, the differences between different large groups of species from one to the next, goes vastly beyond what is practically necessary, right? From an engineering standpoint, from any practical standpoint, it goes vastly beyond what is actually necessary. And in nested hierarchical patterns, and I was also going to talk about how this is exclusively consistent with the theory of universal common descent of life on Earth, right? So the diversity of life on Earth, whether or not it's practically necessary, right, for practical purposes, there are many standpoints that we could look at that from. One standpoint would just be, practically necessary for the basic functions of life, for the species to be able to continue on existing, surviving, reproducing. From those basic standpoints, the diversity of life obviously goes vastly beyond what is necessary, right? We see groups, specialized in different directions, right? But really, so many, one way or the other way would just as well work from that basic standpoint, right? Another standpoint that we could look at it is the usefulness of the biodiversity to humans, or even towards other life forms in general within the broader ecosystem. And we also know from that standpoint that the biodiversity of life on Earth goes vastly beyond what is really practically necessary, because yes, species are very codependent on each other within the ecosystem, which is a prediction of evolutionary theory that would be the case, because species are evolving alongside each other. They're each part of each other's environment if they are in the same environment, and so as they adapt to their overall environment, which includes each other, right? But while that is the case, we also see from the fossil record that it is very clear that there are very large entire groups, right? Large groups that are no longer there. They're extinct, totally gone, right? And we see even alive today, right, that not all regions of the world are equally diverse in the life forms that they have, right? In part because certain groups of living things cannot survive in certain environments, right? And yet other groups of life forms that we commonly see in other parts of the world also still survive and thrive in these environments. So for example, Greenland, within all of Greenland, right, there are no reptiles native there, no amphibians, right? And yet there are still many birds and mammals, right, including humans, right, because we're mammals, right, many that, survive and thrive in Greenland, right? And so it did not actually have to be the case that reptiles or amphibians would exist in order for mammals or birds to exist. It is not necessary, right? And so the diversity of life also goes vastly beyond what's practically necessary from the standpoint of the codependencies of different groups within the broader ecosystem, right? And then another standpoint we could look at it from is just what's impressive to us humans, what impresses us, right? Which is to some extent very subjective, right? And it isn't really inherently efficient per se, right? It isn't like inherently useful. It's just like, oh, wow, that's cool, that's impressive, but still very remarkable nonetheless. Certain features that living things have, like a bird's ability to fly, a cheetah's ability to run as fast as it does, a gibbon's ability to swing as fast as it does, right? And yet we also see with these various impressive abilities that different groups of living things have, that also in that case, that the diversity of life goes vastly beyond what is practically necessary, right? So you see, for example, that yes, birds fly, but bats also fly, and yet bats are mammals, right? And so a bat has a vastly more similar anatomy in every system of its body to a camel, to an elephant, to a human, to a seal. It has a vastly more similar anatomy to all of those than it does to a bird in every system of its body and in predictable ways, right? Its respiratory system, immune system, skeletal, digestive, reproductive, integumentary, nervous, even its circulatory, etc. And I've talked about this on other videos, right? And all in predictable ways, right? A bird is also bipedal. Humans are bipedal, right? And we're mammals, right? We are also mammals, right? And yes, a bird, it can see more colors than mammals can. Most birds can, right? And yet it does not really need to be the case that mammals see as few colors as mammals do, right? Part of how we know that, right? So most mammals have dichromatic vision, meaning they have two cone photoreceptors, right? And yet catarrhine primates, including old world monkeys and apes, and therefore including humans, catarrhine primates have trichromatic vision, right? And that's a group of hundreds of species, all mammals, and we see trichromatic vision across the group, right? And it's self-phylogenetically predictable, right? That is predictable based on which groups that things are a part of, right? Predictable based on other shared traits, like all catarrhines, including humans, also have the dental formula 2123, 2123, right? And so it does not have to be the case that, for example, that we don't have all mammals having trichromatic vision or most mammals having trichromatic vision, right? There's really no logical reason why it should have to be the case that mammals do not have tetrachromatic vision, right? Especially when you see how very, very narrow, very precise that the setup of mammals is, that it's going all the way down to the molecular level. And, the fact that the mammal group predicts, the fact that something is a mammal predicts very specific things, like almost all mammals, no matter how long their neck is, have exactly 7 vertebrae in their neck, right? Even giraffes, right? The only 2 living exceptions are sloths and manatees out of thousands of species of mammals, right? organized into hundreds of families of mammals, right? The vast majority of them having exactly 7 neck vertebrae, which again, practically speaking, there's really, like, if it was down to physics, there's no reason it has to be that way. You have mammals with different head sizes, different forms of locomotion, different neck lengths, differences of how the head is positioned to the neck, differences of how large the blood vessels within the neck are, differences of how strong the joints within the necks are, differences of every practical factor that can make a difference, right? And yet we see very narrowly across almost all exactly 7, right, neck vertebrae, right? And we see other features that could have been shared across the mammal group but are not, right? Like the most mammals and only mammals have pinna, right? The external ear cartilage, right? Nothing else does, right? And also all mammals and only mammals have 3 middle ear bones, right? Which, when you think about it, what do those really have to do with anything else that's characteristic of mammals? Practically speaking, nothing, right? Especially when we see how diverse of a group mammals are, right? And yet the bats, right, they hear at much higher frequencies than other mammals. They hear at ultrasonic level, right? It could just as well be the case that all mammals do, right? And yet we see shared across the group 3 middle ear bones. We see the pinna, right? Both of those features that we don't see in other groups, and yet we do not see shared the level of, hearing it to the level of frequency that bats do, right? And then also, if you look at other groups like non-avian reptiles alive today, right? Most of them move around quadrupedal on the ground, and less fast on average, less large than mammals, right? You could just as well have them having the mammal setup, right? Practically speaking, right? You could just as well have, a creature that walks around, does most of the same, impressive activities that a lizard does, right? And being a mammal, right? Same for amphibians, and even in the case of fish. So fish, they have fins, they swim, right? And yet we have many groups of mammals that likewise, they have fins, they swim, right? Whales, dolphins, right? We have the seals, we have the manatees, right? There are many groups of mammals, right, that swim like a fish, right? And so when we're comparing based on the activities that they do that could impress us, right? Really, the whole diversity of vertebrates, right, could be fitted within the mammal group, specifically placental mammals, right? Especially when we consider how narrow the criteria is with certain things within a group like mammals, right? That does not really need to be as narrow as it is, right? With things like the vision, the neck length, right? And so, we see that the diversity of life goes vastly beyond what is practically necessary, right? and in nested hierarchical patterns, right? Mammal, tetrapod, vertebrate, right? And this is exactly what is predicted exclusively by universal common descent of life on Earth, right? Because we also see, right, that we see that there are reproductive dependencies that organisms have, right, where they depend on ancestors producing them, right, through an ancestor-descendant relationship, right? We see that, for example, so you never get an adult human body, right, without it growing from a baby, without eventually what it grows from is a single cell. Every one of us, that's the only known way for a human body to form, is growing from a single cell, right? And that single cell, and many of the later stages of your development after the single cell, it requires the mother's body, right, to grow and develop, right? So what does that tell us? That the first humans had parents, right, just like all preceding humans, right? And we see that these reproductive dependencies are themselves predicted by the nested hierarchical patterns, right? The specific reproductive dependencies are predicted based on what group is something a part of, right? Like placental mammals, right? And shared across groups, right? And so when you put that together, then, right, with our understanding that the whole of the diversity of life on Earth, right, does not really need to be as it is, right? Entire classes of mammals, right? Or I mean, entire classes of vertebrates, right? Do not need to differ as they do, right? The entire differences between bat and bird, or I mean, the entire differences between mammal and bird, right? The entire differences between mammal versus bird, practically speaking, are not actually necessary, right? It does not have to be the case that birds differ as much as they do from mammals, right? We see, right, that there are bats, they fly, and yet they are mammals, right? Humans move bipedal, and yet we are mammals, right? And so birds could just as well have a mammalian setup, right? They did not have to have, the various unique bird anatomy features, right? Like having a two-chambered stomachs, a syrinx, feathers, beak, having a tarsometatarsus, as opposed to alternatively, like bats and like most mammals, they could have had 7 neck vertebrae, 1 lower jawbone, heterodont teeth, pinna, 3 middle ear bones, a diaphragm. Birds do not have a diaphragm. An epiglottis, neocortex, hair, sweat glands, mammary glands, sebaceous glands, lymph nodes, tonsils, live birth, a placenta, teats, umbilical cord, all of that. In all of those ways, every system of the body, a bat has a more similar anatomy to a camel than it does to a bird, and it does not have to be that way, right? The diversity of life is vastly beyond what is practically necessary for any practical purposes. And so, and there is also interesting that there's even a significant extent that creationists, at least most of them nowadays, accept the extent to which the diversity of life does not need to be as it is, because they would often now say that they agree that everything up to the entire taxonomic family levels are all related, which oftentimes is as much as hundreds of species, right? One of their talking points will be that finches, that they adapt and change, but they're still all finches. And yet, it's like, do you realize there are hundreds of species of finches, right? Hundreds of species, right? And so, if you could understand that hundreds of species of finches could all branch back to one original finch species, and if you could understand that there are other groups of birds that have virtually identical, broadly speaking, anatomy to the finches, right? Then why not take it further? Why stop at finches? Why not they branch back to common ancestry with other bird groups and so on and so forth? And really, also, a lot of the difference between different taxonomic families, right, really goes beyond what is necessary, right? Because like I said, right, you have many families of birds, for example, right, that practically speaking, the differences between them could just as well be, it does not really have to be as it is, right? Same with fish, same with lizards. If you saw a lizard from one family versus another, would you even know the difference? You probably would not, right? They all practical purposes, right? Almost the entirety of lizards, right? Could just as well, it does not have to be all of the different families of them. It's mostly different variants of the same basic thing. If you were to see, one lizard outside, you would most likely, they could be vastly, you know, vast differences genetically, right? But for all practical purposes, which by the way, we also do see significant differences within the family level, right? Different species, even species that interbreed, still often have significant genetic differences, right? Um, but I mean, two fish, right? They could even not be the same class, right? And yet, practically speaking, for practical purposes, you would hardly notice the difference, right? They would mostly look the same, right? A coelacanth versus a rayfin fish. And there's, many families of rodents, right, which practically speaking, you could barely tell the difference, right? All practical purposes when it comes to how much are they impressing us, it's mostly the same thing, right? Different variants of the same thing, right? Different families within the whole rodent group. Even there are many other groups of mammals that, from what you can see from the surface level, right, could about just as well be rodents, right? Hyrax, right? Possums, right? And so the diversity of life on Earth, right, goes vastly beyond what is practically necessary and in nested hierarchical patterns, right? And we have these reproductive dependencies of, offspring depending on the parents in producing them. And we see that, new species branch off one from the next. We see that happen in real time. And so all of this is exclusively consistent, right, with universal common descent of life on Earth, right? Um, because the nested hierarchies and the reproductive dependencies go all the way down to the cellular level and include all life on Earth. And so, all right, that's all for now. See you guys.